Hello there. This is your friendly neighborhood Oasis engineer, and today we're going to create a Sapphire-Native dApp. Let's get started. So first, we're going to have a new hard hat project in our directory. Let's have an empty directory right now, and we are currently limited to hard hat 2.12, and we do have work in progress to patch the Sapphire paradigm to catch up to the latest minor version of hard hat. So while Node.js is helping us get all these dependencies installed, let's take a look at our next steps. So we'll have our editor open to the Sapphire app, and we see that this is the base hard hat contracts that we start with. And let us just give npm a little bit more time. I think we are almost there. Okay, cool. So Sapphire Hard Hat is our Sapphire plugin for Hard Hat. Let's install it. This should be a lot quicker. And there, it's done. So now that we have our dependency, we can bring it into the hard hat config file. And of course, with every new network, we must add basic information as configuration. So let's do that. And we'll just clean this up a little bit. There. So the purpose of the Sapphire Hard Hat package is to make sure that the transactions are transferred correctly into the Sapphire format. And to demonstrate, we'll take a look at an example smart contract. And let's bring it into our local directory. So the thing to highlight here is that both secret metadata and secrets are private variables that will not be revealed. And you're welcome to go through the details of this documentation. So secret will have a getter and setter. However, it cannot be read by normal means, and we'll demonstrate that very shortly. Let's come back and make sure that we also cover our TS script. So run visual will both cover the deployment of the visual smart contract and go through and create an actual secret. So what we have is that we'll then try to test our smart contract by trying to reveal the secret. And it should actually fail because not enough time has passed. And we'll try again with enough delay, which should hopefully reveal the secret that we tried to store in the first place. Let's just try it. So we'll come back here, and we'll use a very similar setup that we did before, where we stored the private key as an environment variable, which I have done before starting this video. So we'll be able to run this portion of the command. Let's do it. So, of course, we do have to compile to Solidity smart contracts. So, including the lock one that comes with a new hard hat project. But we are just deploying the visual smart contract. And once we get to this point, we should actually be able to see that smart contract address inside of our testnet explorer. We'll see that the contract is created and called. What happened? Failed to fetch secret, call revert exception. So no such secret exists. This is what we expected. We expected that smart contract would protect the secret on the first call. But when sufficient conditions are met, the smart contract will reveal the correct secret on the second call. And there we have it.